You know, every time you get on an international flight, you're relying on this massive, totally invisible system. It's like a universal language for weather, one that makes sure a pilot in Tokyo understands a storm over New York, no questions asked. This hidden shield has a name, Annex 3.
Think about it. Right now, there are thousands of planes up in the air, weaving through a minefield of invisible threats. You've got volcanic ash that can literally choke an engine, solar flares that could just sever communications. So how on earth do they all stay safe? Well, the secret is a single global rulebook that everybody, and I mean everybody, has to follow.
So, let's pull back the curtain on this whole thing. We're going to start with the rulebook itself, and then we'll crack the secret codes that pilots use every single day. After that, we'll dive into how the system warns about those crazy in-flight dangers, meet the global network of weather watchers, and finally, really get into why this all matters for your next flight.
All right, first up, the global rulebook itself. Let's talk about the purpose and the very real power behind something called Annex 3.
The easiest way to think of Annex 3 is like a universal translator for weather. It's this one single document that guarantees a pilot flying out of Tokyo gets and understands weather info from Cairo or New York, just as if it came from their own home base. There's no room for ambiguity, no chance for misunderstandings, just one clear language of safety.
So how does this rulebook actually have teeth? Well, it all boils down to two very simple words, shall and should. If a rule says you shall do something, that's a mandatory standard. You absolutely have to comply. If it says you should, well, that's a recommended practice. It's not, compulsory, but it's a very, very good idea for safety. This simple little distinction is what makes the entire global system work.
Okay, so let's move on from the theory and see how all this gets turned into the practical, critical information pilots use every single day on the ground.
Now, this might look like a line of complete gibberish, but to a pilot, it's a story. The string of letters and numbers is called a METAR, and it's a complete snapshot of the weather at an airport at a single moment in time. It is the final critical piece of the puzzle before they even think about pushing back from the gate.
And this right here is the power of standardization in action. Let's break it down. We're at Montreal CYUL. The report is from the 24th of the month at 700 Zulu time. The wind is coming from 270 degrees at 18 knots with gusts up to 30. Visibility is 5,000 meters in snow, and for clouds we have a few at 2,000 feet and a broken layer at 4,500. See? In just a handful of characters, a pilot anywhere on the planet gets a crystal clear picture of the conditions. And the level of detail is just incredible. This is just a tiny sample of all the standardized abbreviations. I mean, everything from drizzle, DZ, to a sandstorm, SS, and even volcanic ash, VA, has its own unique code. This makes sure absolutely nothing gets lost in translation. But what about dangers that pop up after a plane is already in the air? Well, that's where warnings for hazardous skies come into play.
Let's start with one of the absolute most serious threats to a modern jet aircraft, volcanic ash. These are tiny, fine particles of rock and glass, and they can melt in the intense heat of an engine, then solidify on the turbine blades and cause a complete catastrophic engine failure.
To fight this invisible threat, Annex 3 set up a global network of volcanic ash advisory centers, or VACs. You can think of them as detectives for the sky. They use satellites and really complex models to track ash clouds, predict their every move, and issue warnings that tell pilots exactly which chunks of the sky have become no-go zones.
All right, next up is a hazard that's known for its just sheer scale and terrifying power, the tropical cyclone. And for these absolute behemoths of nature, we have Tropical Cyclone Advisory Centers, or TCACs. These centers are home to the world's leading experts on these storms. They provide that critical data, position, speed, intensity, that allows air traffic control to route hundreds of flights safely around the danger.
Okay, now for a threat that's a little more modern and maybe less obvious. This one starts 93 million miles away from Earth. We're talking about space weather. Believe it or not, for a pilot, space weather can be a total nightmare. Solar flares can black out high-frequency radio and completely scramble GPS signals. They can even pose a radiation risk to passengers and crew on high-altitude polar routes. And that's exactly why we now have space weather centers, the SWXCs, which act as our early warning system for solar storms, giving airlines the critical heads-up they need to stay safe.
So we have all these specialized centers for all these different threats. Let's zoom out for a second and look at the bigger picture, the global network that connects all of these dots. So you've got your VACs for ash, your TCACs for cyclones, and your SWXCs for space weather. But here's the thing,
They don't operate in a vacuum. They are all interconnected pieces of a much larger global network that forms the very backbone of aviation weather forecasting.
And that backbone is the World Area Forecast System, or WAFS. Think of it like this. There are two massive weather supercenters, one in the UK and one in the US, that generate these enormous global weather forecast models. They provide the fundamental data, wind, temperature, humidity, all of it, in one single digital format that the entire world plugs into for flight plan.
So the crucial point is, does it all work? Does this incredibly complex system of rules and codes and centers actually hold up when it's truly tested? Well, in 2010, the system faced its biggest test in modern history. The Eyjafjallajökull volcano in Iceland erupted, and it spewed a gigantic cloud of abrasive, engine-killing ash right into the busiest airspace in the entire world, right over Northern Europe. This was the exact moment Annex 3 was built for. The London VIAC became the nerve center of the entire crisis, working 24/7 to track that ash and predict its path. Their clear, standardized warnings led to a decision that had never been made before, shutting down a massive chunk of the world's airspace. Now, it caused absolute chaos on the ground for sure, but in the sky, the system held. Not a single plane was lost to that ash.
And you know, that really gets to the core philosophy behind Annex 3, which is captured perfectly right here in this quote from the document. The system isn't about promising certainty. Weather is way too unpredictable for that. It's about providing the most probable value, giving everyone the best possible information, standardized for the whole world so they can make the safest possible decisions.
So from a single line of code about wind at an airport all the way to a global response to a volcano, Annex 3 is the silent guardian of our skies. It's adapted to threats from deep within the Earth to the far reaches of our solar system. Which really only leaves one question: what invisible danger will it have to conquer next?